Welcome. Today we're diving into the fascinating world of Newton's laws of motion. These three simple yet powerful laws form the foundation of classical physics and help us understand how objects move and interact. Whether you're watching a soccer ball soar through the air or a car coming to a stop, Newton's laws are at play. In this video, we'll break down each law, explore real-life examples, and see how they shape the world around us. Let's start our journey by learning a bit about the man behind these groundbreaking ideas, Sir Isaac Newton. Isaac Newton was a brilliant English mathematician, physicist, and astronomer who lived in the 17th century. He made groundbreaking discoveries in many fields, but he's best known for his work in physics. Newton's curiosity about the natural world led him to develop the three laws of motion, which forever changed how we understand movement and force. His insights not only explained why apples fall from trees, but also laid the groundwork for modern science and engineering. For Newton, people had many ideas about how objects moved, but there wasn't a clear, unified explanation. Newton's laws brought clarity and consistency to the study of motion. They provided a framework that scientists and engineers still use today. These laws help us predict how things will move when forces act upon them, from the smallest pebble to the largest planet. Let's begin by exploring the first law, often called the law of inertia. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. This is called the law of inertia. In other words, things don't start moving, stop, or change direction all by themselves. Something has to cause that change. For example, a soccer ball won't roll unless you kick it, and it won't stop unless friction or another force slows it down. You experience inertia every day. Imagine you're riding in a car that suddenly stops. Your body wants to keep moving forward, which is why you lurch ahead. That's inertia in action. Seat belts are designed to protect you from this effect by holding you in place when the car stops quickly. Inertia explains why it's harder to push a heavy object than a light one. The heavier object resists changes in its motion more strongly. Let's look at sports. When a basketball player dribbles, the ball keeps bouncing until the player stops it or friction slows it down. The ball's motion continues because of inertia, and only an outside force, like the player's hand or the floor, can change its movement. This principle helps athletes control the ball and make precise plays during a game. Now let's move on to Newton's second law of motion. This law explains how the force applied to an object, its mass, and its acceleration are all connected. It's often written as F equals ma, where F is force, m is mass, and a is acceleration. This law helps us calculate how much force is needed to move an object or change its speed. According to the second law, the greater the force you apply to an object, the more it will accelerate. But if the object is heavier, has more mass, it will accelerate less for the same amount of force. For example, it's easier to push an empty shopping cart than a full one. The empty cart has less mass, so it accelerates more when you push it. Think about riding a bicycle. When you pedal harder, you apply more force and the bike speeds up. If you're carrying a heavy backpack, it takes more effort to reach the same speed because the total mass is greater. This is Newton's second law in everyday life: force, mass, and acceleration working together to determine how things move. Let's do a quick calculation. If you push a 2 kg object with a force of 10 newtons, how much will it accelerate? Using the formula F equals ma, we rearrange it to equals Fm, so equals 10 n/2 kg equals 5 ms2. This simple math shows how Newton's second law lets us predict motion in a wide range of situations, from launching rockets to tossing a ball. In sports, athletes use the second law all the time. A baseball pitcher throws the ball with a certain force, and the ball's mass determines how quickly it accelerates toward the batter. The same principle applies in soccer, basketball, and even swimming. Force, mass, and acceleration are always at play. Now let's talk about Newton's third law of motion. This law states that for every action there is an equal and opposite reaction. Whenever you push on something, it pushes back with the same amount of force in the opposite direction. This law explains why rockets launch, birds fly, and we can walk on the ground. When you walk, your foot pushes backward against the ground pushes forward with an equal force, propelling you ahead. This is Newton's third law in action. Without this reaction force, you wouldn't be able to move forward. The same principle applies when you jump. The ground pushes you upward as you push down. A dramatic example of the third law is a rocket launch. The rocket engines push hot gases downward, and the gases push the rocket upward with equal force. This equal and opposite reaction is what allows rockets to escape Earth's gravity and travel into space. It's a powerful demonstration of Newton's third law at work. Birds use Newton's third law to fly. When a bird flaps its wings, it pushes air downward. The air pushes back, lifting the bird into the sky. This action-reaction pair is essential for flight, whether it's a tiny hummingbird or a massive eagle soaring above the trees. Swimmers also rely on the third law. When you push water backward with your hands and feet, the water pushes you forward. This equal and opposite reaction helps swimmers glide through the pool and win races. Every stroke and kick is a perfect example of Newton's third law in action. Let's quickly recap. Newton's first law is about inertia. Objects resist changes in motion. The second law connects force, mass, and acceleration, showing how they work together. The third law tells us that every action has an equal and opposite reaction. Together, these laws explain almost everything about how objects move in our world. Newton's laws of motion are more than just scientific rules. They're tools we use every day. Engineers rely on them to design cars, airplanes, and bridges. Athletes use them to improve performance. Even video game designers use these laws to create realistic movement in virtual worlds. Understanding Newton's laws gives us the power to predict and control motion in countless ways. Transportation is a great example of Newton's laws in action. Cars, trains, and airplanes all rely on these principles to move safely and efficiently. Brakes use friction to stop vehicles, first law, engines provide force to accelerate, second law, and wheels push against the ground for movement, third law. Space travel wouldn't be possible without Newton's laws. Rockets use the third law to launch, and spacecraft rely on inertia to coast through space. Engineers calculate the exact forces needed to send satellites into orbit or land rovers on distant planets. Newton's insights continue to guide our exploration of the universe. Architects and engineers use Newton's laws to design safe buildings and bridges. They calculate how forces like wind and gravity will affect structures, ensuring they remain stable and secure. Understanding motion and force is essential for creating everything from skyscrapers to playgrounds. Athletes constantly use Newton's laws to improve their performance. Sprinters push off the starting block's third law, cyclists adjust their force to accelerate, second law, and gymnasts use inertia to control flips and spins, first law. Physics is everywhere in sports, helping athletes reach new heights. Newton's laws aren't just for scientists, they're part of our daily lives. From opening doors to riding bikes, every movement involves these principles. Even simple actions like tossing a ball or jumping on a trampoline are governed by the laws of motion. The more you notice them, the more you'll appreciate how physics shapes your world. Modern technology relies on Newton's laws. From designing smartphones that withstand drops to creating drones that fly smoothly, engineers use these principles to solve real-world problems. Understanding motion and force helps inventors create safer, more efficient devices for everyone. Nature is full of examples of Newton's laws. Trees swaying in the wind, rivers flowing, and animals running all follow the same rules of motion. Even the orbits of planets and moons are explained by these laws. Physics connects everything in the natural world, from the smallest insect to the largest mountain. Teachers use Newton's laws to help students understand science. Simple experiments like rolling balls down ramps or launching model rockets bring these concepts to life. By seeing the laws in action, students develop a deeper appreciation for how the world works and the power of scientific thinking. Safety equipment like seat belts, airbags, and helmets are designed using Newton's laws. These devices help manage forces during accidents, protecting people from injury. By understanding how motion and force work, engineers create safer cars, bikes, and sports gear. Artists sometimes use Newton's laws to create dynamic sculptures or kinetic art. Moving parts, balanced forces, and motion all come together to make art that's both beautiful and scientific. These works show how physics can inspire creativity and innovation. Doctors and medical engineers use Newton's laws to design prosthetics, wheelchairs, and other medical devices. Understanding how forces act on the body helps create equipment that's comfortable, efficient, and safe for patients. Physics plays a vital role in healthcare innovation. Movies and video games use Newton's laws to create realistic action scenes and animations. Special effects teams simulate explosions, car chases, and superhero feats using the same physics that govern the real world. This makes entertainment more exciting and believable. Robots are designed using Newton's laws to move, lift, and interact with their environment. Engineers calculate the forces needed for robots to walk, pick up objects, or even dance. Understanding motion and force is essential for building advanced robots that can help in factories, hospitals, and homes. Airplanes rely on Newton's laws to take off, fly, and land. Engines provide the force needed for acceleration, wings use reaction forces to generate lift, and inertia keeps planes moving smoothly through the air. Pilots and engineers use these principles to ensure safe and efficient flights. Boats and ships also follow Newton's laws. Engines push water backward, third law, hulls resist changes in motion, first law, and the force of the wind or propellers determines acceleration, second law. Understanding these principles helps sailors and engineers navigate the seas safely. Farmers use Newton's laws when operating tractors, plows, and other machinery. The force needed to move heavy equipment, the inertia of large vehicles, and the reaction forces from the ground all play a role in modern agriculture. Physics helps make farming more efficient and productive. The shipping and delivery industry relies on Newton's laws to move packages efficiently. Trucks and planes use force to accelerate, inertia keeps cargo moving, and reaction forces help with loading and unloading. Logistics companies use physics to optimize routes and ensure safe delivery. Even in finance, Newton's laws offer useful analogies. For example, market inertia describes how trends continue unless acted on by new information, first law. Sudden changes in market force can accelerate or slow down economic activity, second law, and every action in the market has a reaction, third law. Communication systems like satellites and cell towers rely on Newton's laws to stay in orbit and transmit signals. Engineers calculate the forces needed to launch and position satellites, ensuring reliable connections for phones, TV, and the internet. Meteorologists use Newton's laws to predict weather patterns. The movement of air masses, the force of the wind, and the inertia of storms all follow the same principles. Understanding motion and force helps scientists forecast everything from gentle breezes to powerful hurricanes. Game developers use Newton's laws to create realistic movement and interactions in video games. Characters jump, run, and collide just like in real life thanks to physics engines that simulate force, inertia, and reaction. This makes games more immersive and fun. Educational apps and tools use Newton's laws to teach students about motion and force. Interactive simulations let learners experiment with different scenarios, deepening their understanding of physics. These digital resources make science more engaging and accessible. Space missions, like sending probes to Mars, depend on Newton's laws for planning and execution. Scientists calculate the forces needed for launch, the inertia of spacecraft, and the reaction forces during landing. These principles ensure successful missions and new discoveries. As technology advances, Newton's laws remain essential. From self-driving cars to space tourism, understanding motion and force will help us solve new challenges and explore new frontiers. The future of science and engineering will continue to build on Newton's timeless insights. No matter who you are, Newton's laws affect your life every day. From the way you move to the technology you use, these principles shape your experiences. By understanding the laws of motion, you gain a deeper appreciation for the world and the science that makes it work. Let's take a moment to review what we've learned. Newton's 3 laws of motion explain how and why things move. They're the foundation of physics, engineering, and so much more. By noticing these laws in action, you can better understand the world and even predict what will happen next. Newton's laws of motion are more than just scientific theories, they're powerful tools that help us shape our world. From everyday activities to cutting-edge technology, these laws guide our actions and inspire new discoveries. Keep exploring, stay curious, and remember, physics is everywhere.